Hello, how's it going, everyone? I am Jake. It is great to be here virtually at Hack in Paris. This is going to be my talk on incident response, and that's coming from my background in emergency healthcare. Cool. So yeah, I'm Jake Byman. I am a software engineer. I live in the San Francisco Bay Area. I work currently at a Seattle-based startup called Common Room. Before Common Room, I worked at Slack for a little over 4 years on the enterprise product. Primarily, my background is mainly in application engineering, specifically in the back end, but I've dabbled across the stack. So outside of my work as a software engineer, I've actually worked as an emergency medical technician for the better part of around 7 years. And during that time, I've worked in 911 response, as well as non-transporting first response, as well as standby medicine in areas like concerts and events. During that time, I've also responded to various calls. They range from small cuts and bruises to severe cardiac, traumatic, and medical emergencies. So why am I here? Well, I am talking about software incident response and how it ties into my experience with emergency medical response. My background is not particularly security related, but these tools that I'm going to be talking about here should generally be fairly reusable in most software contexts. Simply, this talk is actually not super technical in nature. It's fairly general, and it's rather geared towards folks who are curious about emergency response and software incidents and how they might overlap. So I'm going to talk a little bit about what incidents are and how they can be a helpful tool. I'm also going to talk a little bit about emergency medical response and how that works. I'm also going to be talking about things like stress management and blamelessness. And then I'll also talk about some tips that I've learned just from my experience, and yeah, then I'll wrap things up. So before we get started, I do want to just give fair warning that some of this talk does have some anecdotes and references to some fairly morbid content from my time as an EMT. Just in case anyone is triggered by this, I do want to give ample warning about that. Cool, so let's dive in. Cool. So before defining how a software incident works, I would like to talk briefly about how this kind of works in the emergency medical world with these things called mass casualty incidents. So in EMS and firefighting, we have this concept of a mass casualty incident. It's more commonly called an MCI. And that entails an emergency where there are more patients than providers that can treat them. So an example here is a building collapse, bus crash, some events similar to those. When a single first responder has one patient to deal with, that's okay, that's manageable, that's the usual scenario. However, in a single incident, there may be 2, 3, or 10 patients for every single responder. And when that happens, you as a responder need to decide who gets treatment and when. So an MCI is a situation in which you need to triage those individuals and manage your logistics and resources carefully and deliberately. So an important part of the MCI process is triage. So before treating anyone, you need to gain an assessment of what's going on. To do this, the triage teams are going to search the scene for any patients, and they'll get a very quick overview of the state of that patient. And based on that, they'll assign a color based on how severe they are. This should take no more than 15-20 seconds a patient. In California, we use a triage system called START triage. It's pretty common. The order in that triage system is green, yellow, red, and black. Someone with a green tag is in pretty good shape. They may have some cuts and bruises, but generally are able to walk and seek medical treatment. We usually call those walking wounded. Yellow indicates that they are unable to move to seek medical treatment, but are otherwise okay. These patients, for example, might have like a broken leg. They are stationary, but otherwise they're doing all right. So then we're getting into red, and these are patients that are requiring immediate treatment. These are the highest priority, and generally these are the ones that you're going to have the highest likelihood of helping. And finally, there are black tags, which are the ones that you do not think you're going to survive, and generally are going to be deprioritized in favor of the red tags. Sorry, that was a bit of a morbid note to start on. I promise it is relevant. So the goal in these emergencies is to determine everything that's wrong and prioritize getting it as close to fixed and getting our patients better as fast as possible. That being said, not everything needs to be addressed at once. So you, as an EMT, as a firefighter, need to effectively manage your time and resources. An incident in the software world is a tool used to manage these equivalent software emergencies. Obviously, there's decoupled, but for the metaphor's purpose. Some examples of incidents are some users are unable to log into our servers. A database shard is completely down. Maybe a malicious actor might have gotten access to some sensitive information. I stumbled on this definition that ServiceNow put out, which I really liked. An incident is an occurrence that can disrupt or cause a loss of operations, services, or functions. Incident management describes the necessary actions taken by an organization to analyze, identify, and correct problems while taking actions that can prevent future incidents. There are a lot of pieces of enterprise software that are dedicated specifically for solving incidents. I don't personally have any affiliation with them, but some of these include PagerDuty, ServiceNow, OpsGenie, SolarWinds, Freshservice. For the purpose of this talk, I'm just going to talk about the bare bones core concepts of responding to an incident outside of any independently of any existing software solutions. So in medical emergencies, we have various roles to resolve things like MCIs and other medical incidents. Some of these roles are the incident commander. That is the actual term used in MCIs. And their job is that they are in charge of managing the flow and prioritization of the overall incident. Under that, we have teams like triage teams, which are prioritizing patients using start triage. You have rescue teams that might be going into buildings and extricating patients. You can have a logistics team managing what equipment you have, an operations team managing things like radio communications, and several other teams that are involved in that incident. In software incidents, you might have several types of roles as well, including incident commander, subject matter experts, liaisons for any customers affected, someone scribing details of outages, and other roles that you think might be necessary. The subject matter experts in our world are often engineers who are working to write and run scripts, for example, or patch code in order to resolve an issue. The architecture of these, both medical and software incidents, are actually pretty similar. So here's what a 911 call would look like. The flow here is that someone would witness an emergency and then they decide to call 911, or depending on which country you are, it might be 999, et cetera. The 911 dispatchers will listen to the nature of the emergency and decide which resources to send, depending on the nature of it, if that could be fire, medical, police. And when the actual responding units gets to the patient, the responding units can also request additional resources as they learn more information. We can model the incident response similarly, where we have a workflow where someone might notice an influx of new customer tickets, or to have this not reliant on a human, you can have an automated alert that might automatically page an engineer when an alert threshold gets too high. At your company, you might have some incident response process where that could be activated, and then the incident commander, whoever might be on call, they would decide which teams to page based on the nature. So if the report is pertinent to security, you might be able to page application security team, a cloud engineering team, billing team, or whichever team is pertinent for this particular issue. So let's talk about what incidents are good for. They can be super helpful for managing a streamlined response for an emergency. So generally, it entails creating this environment in which responders can dedicate time and resources to resolve an issue. For example, you might have a Slack or Discord channel dedicated to resolving an issue in which the subject matter experts, the incident commanders, and everyone else can discuss a strategy for getting back to getting back to a good state. Similarly, incidents, even outside of the incident itself, they can be a good archive. So they can be used to prevent future incidents by providing history and of what happened and why. That being said, incidents are not the right tool for everything. I've seen it be used just to escalate a frustrating bug, which is, in my opinion, not the right use for that streamlined response. Another misconception during these software incidents, these software emergencies, is that you need to solve everything to be back to 100% perfect, when in reality, my philosophy is that the goal should be to get back to a stable state, where having everyone talking about an issue, everyone swarming on an issue might not be needed. For example, if you had 1,000 users that were deactivated, and a handful of those users needed some extra scripts, extra TLC to be completely restored, maybe you don't need everyone swarming on this issue. Maybe you can downgrade and deal with those as in a normal bug fashion. Incidents have various severities generally. You might hear them also referred to as SEVs sometimes. That's what this is referring to. You can define your own severity levels at your company, but generally they fall into around 4 categories, where you have SEV 1 or SEV 0, and that could be an outage level event where all or most users are, for whatever reason, unable to access your service. It can also not be a user-facing issue. It might be a high priority workflow, a high priority security issue, or something that some tooling that's broken internally that's preventing everyone from doing their job. On the other side of the spectrum, you have things like severity 4 incidents, and those are probably less serious, where maybe only a handful of users are experiencing an issue. But again, you can calibrate these severities based on your own definitions. In the incident management in emergency services, we have this concept of CAN reports. Those are typically in California Fire, where you are regularly reporting the conditions of the situation, the actions that are being taken, and any needs that you might have. You can use a similar tool in software incident response, where you might use these reports every 15 minutes or so. The idea here being to let everyone know what the state of the world is, say, hey, we're working on it, this is who's doing what, and this is what we need to do. These updates are really just meant to provide an immediate understanding of the current situation. So where we are and where we need to be. At the very end, after the incident is cleared and everything is back to good, it's helpful to have a debrief, often referred to as a post-mortem. So the idea here is to ask what went wrong, how did we as a team respond, how could we have responded better, and an important question is, how could this have been avoided in the first place? This is a good stage to assign any action items, such as monitoring, alerting for things that customers reported, etc. So one question that's often asked is, when is something an incident versus just a bug? And generally, there's no clear answer. It depends on what your company's definitions and parameters are of what's acceptable behavior. A general heuristic that I would personally ask is, if someone reports something, if you're dealing with it around the end of the day, could you safely walk away and have it be acceptable from your customer's point of view? So let's go over an example. So hypothetical example, you have a scenario where a disgruntled employee decided to delete 10,000 users in your service. Several users have written in that they can't log in. The customer team that's managing all the tickets, they see an influx of new tickets and they decide to declare an incident. The incident commander who's on call, they join the incident, and based on the reports and based on the company's protocol, they decide to classify this as a severity 2 incident. The incident commander then decides to page in the security and infrastructure teams. The incident commander delegates to security to disable the user's token and the infrastructure team to spin up a database backup. Meanwhile, the customer engagement team, they decide to update the website and the Twitter account, letting users know that there is an ongoing issue. Every 15 minutes, the incident commander decides to provide an update of the state of the incident, of how things are going and where we need to be. Once the malicious user's token is disabled and the users are then re-provisioned, the incident commander asks the customer team to check in with the affected users to confirm that their accounts are fixed. After the customers confirm that the issue is resolved, the incident commander then clear the incident and unstage the responders. The next day, responders decide to meet and talk about the incident, have a post-mortem, and talk about how it could have been avoided in the first place. Cool. That's generally how an incident works. So one natural part of incidents is stress. So let's talk about stress management. So I've seen incidents that can last hours or even days, depending on the severity. So during this time, you as a responder, you might feel stressed. Users aren't able to log in. There might be executives on the call. Everyone, the users, you, the entire company, they want it to be resolved. That can be a lot of pressure. Reducing that stress is definitely important, but it's also, in my opinion, important to remember that these types of issues, these types of emergencies, they are natural as part of any software company, and they're just natural as part of any growing organization. That being said, I definitely think checking in with yourself and prioritizing your mental well-being is extremely important here. So have you been working at this issue for hours? Do you maybe need something to eat, or maybe you just need to go on a walk and clear your head? I would strongly suggest asking your incident commander for some time. You are not going to be productive by burning yourself out. You're not going to be a good responder that way. It's not going to be helpful for getting back to green. Cool. Story time. So when I was first becoming an EMT about 7 or 8 years ago, I was extremely nervous for my first shift on an ambulance. My first 911 call was an 84-year-old male who was having difficulty breathing. So we responded red lights and sirens, also called code 3. And that's indicating that it was a severe emergency where we needed to prioritize the response. So we get on scene and we take a look at the patient, and I was immediately terrified. This is my first emergency. The patient who's having the difficulty breathing, they took a look at me and they saw my terrified look, and they managed to ask me, "Are you okay? You look like you're about to faint." That's not the goal for an EMT. They should generally not, the patient should generally not be asking you if you're okay. Let's talk a little bit about blamelessness. So what is blamelessness? You may have heard the term come up a couple times. The idea here is that an incident or some failure event, there is no single person who should be at fault. Blamelessness, I think, is something that is ingrained into culture, into your postmortems. If engineers are being solely blamed for issues, they are going to ship code more slowly, fearing being blamed for anything that could go wrong. Instead, my suggestion would be to ask, why didn't unit tests catch this issue? Were there any automated tests that could have done this? Any linters? Could this have been caught in a pull request review? Did any alerts or pages go off? In the same vein, one thing I see engineers doing in incidents is apologizing. They're saying sorry for making these changes. I would personally suggest to stop apologizing. Instead, focus on strengthening the system and moving forward. Apologizing actually goes against the idea of blamelessness because self-blame is indeed a form of blame. And I can chat a little about some tips I've learned. So one tool we use in the EMS world is to stage fake emergencies for folks who are training. You might have heard the phrase, practice how you play. Well, we use that same philosophy for training for emergencies. So I, as the fake emergency proctor, I would call the responding unit and give them a prompt. I would say, for example, EMS 1, please respond to 21 John Street for a 34-year-old male reported unresponsive. This would be a classic example of a 911 dispatch. The responding unit would respond and they would have a patient who is just a stage actor in this case. The EMT who is training would go through the full call as usual. And they would say, for example, the patient has a blood pressure of 120 systolic over 70 diastolic. The proctor of this call would then correct the EMT and say, for this call, your patient's blood pressure is actually 90 over 60. These types of mock emergencies have proven to be extremely successful in training EMTs to prepare for the real stress of medical emergencies. One thing that we try to do is something similar with software incidents. You would prepare a possible user scenario. For example, users are reporting that they're unable to log into our service and are reporting slowness across the application. So depending on how your company does incident response, you could create a dedicated chat with the responding people and go through the scenario. A responder might say, okay, I'm going to look at the logs. And you as the proctor might say, okay, the logs are showing that there are timeout errors when the service is reaching out to the database. So after that, the responders would go through the incident as if it were real. The idea here being to simulate the real thing. And you can get pretty creative here. I've seen a lot of really creative mock incidents. And at the end of it, you would have a similar post-mortem experience where you'd end up writing new scripts, adding new alerts, or anything that you might have learned while going through the exercise. There are a couple of use cases for mock software incidences. The main one I've seen is for onboarding engineers to, for example, an on-call system, or just to get them used to being responsible for maintaining the team's features. Another use case is just trying to think of the worst case scenario for a new feature that you're shipping, just as an exercise to get used to that kind of stress, but also to say, okay, what's the worst case that could happen with this feature? And even if you don't have a practical reason, these things are a lot of fun and they're good practice, even if you're a veteran and you're just looking to exercise that muscle. Another tip, in startups, it can be definitely tricky to clearly define which team owns what. As companies get bigger, knowing which team to bring in for an issue with a certain feature, I believe is essential. Accidentally paging the wrong team at 2 a.m. for an incident that they don't have context on can be awkward. I am definitely speaking from personal experience there. During an incident, there might be several things that are going wrong at the same time. There could be 10 different issues all stemming from the same one. And in that case, there may need to be several work streams needed to resolve that incident. For example, if a database shard fell over, one work stream might need to spin up a backup database shard. Another might need to flush the cache, and a third team might need to manage the customer communication. Having dedicated individual work streams focusing on one issue at a time, in my experience, has been extremely helpful for getting a clear path to getting it resolved. So one tip is to change the severity of an incident as you're going through it. So if you're going through an incident where it was reported that only a couple of users were having issues, maybe you got 2 or 3 tickets, but after you dig in a little bit, you look through the logs and you see, oh, actually 40–50% of users are actually experiencing this issue. Maybe consider upgrading the response and getting more resources in, making sure that you actually have the people you need there to get it resolved. On the other side of the spectrum, if you think something seems terribly wrong, but you actually find that it's more of an edge case, consider downgrading and allow some people to maybe on stage, and if it's late in the day, maybe allow them to pick it up in the morning. I have another medical story. So I was an EMT in college in upstate New York, and I was working on a Saturday night on a university campus. So typically Saturday night when you have emergencies, that's often going to be something like intoxication. So when we get a call for a college-age male altered, our initial thought was that this was going to be an intoxication call. So we got that call, and once we arrived on scene one night, the patient was not alert and was sluggish in responses. So far, that's not atypical for an intoxication call. However, I took the patient's blood pressure and I found an anomaly where the reading was 190 over 110. For some context, adult male blood pressure should be around 110 over 70. So the patient was altered, but only seemed to remember the past 30 seconds at a time. So we did a little bit more digging into the situation, and a bystander reported that the patient fell and hit their head against the concrete. So we no longer suspected that the patient was intoxicated, rather that they had a severe brain bleed. So when we realized that information, we opted to upgrade our response, and we tried to get a helicopter to expedite that response to get the patient to the hospital faster. Cool. Just to wrap things up here. So it's a lot of information and stories. Why does this all matter? One thing that I found as software companies grow, the more issues happen and the more complex those issues get. Because of that, it's important to have some tool set to address them. So creating dedicated incident response, I think, can be a really helpful tool for streamlining the process. They can also be stressful, and having a blameless culture in which that stress is manageable, I think, is completely necessary for that growth. And lastly, what I'd say is that these incidents are a natural part of any software organization. It's not fun as an engineer when you ship code that you thought was going to work as expected, but it didn't. But to err is human, and it's important to build and learn from those experiences. As a shameless plug, Common Room is hiring. Please let me know if you're interested in a role. We are building some pretty cool stuff. And thank you all for listening. And I am going to leave some time for questions.